So we got our particles, and now we need to turn them into volumes. And before, we had basically particles that started off as just one, and then we applied a noise to it. And we're still going to apply a noise to it, but I don't actually want them to all just be one. Wouldn't it make more sense to be the hottest and most flamiest when the particles are just born and then kind of die out over time? Of course it would be. So let's do that. Let's make a wrangler, and we can use the age and, I should get some particles back. We get age and life. Now life is an attribute that doesn't change per point. It simply records how long the particle will ever be alive for. Actually, it won't even help to show you there. But the life is an unchanging thing that will be from 0.2 to 0.6 because that's what we said, 0.4 plus or minus 0.2. Age is how long the particle has been alive for in seconds. So we can say something like, let's make the temperature be equal to NH. NH is a built-in Houdini thing that does that age divided by life. So how long have you been alive for divided by how long will you be allowed to be alive for. You can literally just type in at age divided by at life if you want, but this is a slightly cooler way of doing it. So I want to see this. Show me temperature. Here we have that issue again where I clicked on it, but I don't see it, because this has to be on. And even right now, I don't want to see the velocity. I only want to see temperature. So I can kind of see it. Make sure hide other objects is on, and I often just find that if you press W and go into wireframe, it shows up better. I'm not 100% sure why that is. But anyway, we see it. We actually see it that it's coolest at the beginning and becomes hotter later. So we want the opposite of that, or rather the complement. So do 1 minus that, and it flips. Because 1 minus 0 is now 1, and 1 minus 1 is now 0. So that's pretty cool. So now let's make the attribute noise. Attribute noise. There you go. So attribute noise can be multiplicative, and we want to do temperature. Oh, and we actually wanted to do not just temperature, we wanted to do burn also. So we can do both at once like this. Temperature equals burn, equals that. So it's just saying them both like that. And just to be a good citizen, I'm going to say density is equal to 1 also. This is kind of just a suspicion I have. I don't think it really matters, but just in case, set density to 1, even though we're not going to source density in. So coming back to this, so temperature, burn. I believe we did animated and remap noise, 0.2. Probably should just copy over the other one. But, you know, maybe we'll get something different this time. So there you go. It's doing its thing. Looks cool. You know, it's still mostly red towards the front, but otherwise, it's the same thing. Sweet. So we need to rasterize attributes. That thing, volume rasterize attributes. We want to do temperature and burn. We'll keep it still at, oh, I'm in wireframe mode. Uh-oh, big boxes. I was gonna say we keep it still at voxel size is 0.1. But now, you know, before when we did the pyrosource, we had p scale get generated based on the particle separation times this, I guess, which in effect was the distance between these particles. So that worked nicely when we were rasterizing it into voxels later. And we don't have that because this is just a particle sim. The particles don't always have the same particle separation. So we need to come up with some value. And I would basically just say, make it small. Like, just make it quite small. Same thing with our voxel size. Obviously, the smaller the voxel size is, the higher resolution that we'll have. You know, it's going to rasterize it so fast still that, I mean, we can make it even smaller. like this, there's still no real, it's still quite fast. This is not going to be the limiting factor for us when we do the sim. So I would say as long as our resolution here is higher, meaning a lower voxel size than our actual sim, then we're fine. Obviously, we don't want to have a lower resolution source than the sim is. Even having a matching resolution source in the sim can still lead to some muddied sources if the voxels don't, like locations in space don't exactly line up, because of the way it has to resample the source into where the sim's own voxels are. But there you go. So we've got a good source. We want to velocity blur it. We want it to blur the whole frame from the current frame to the previous frame. Negative 1 again. Don't know why it always wants to go to the next frame. Blur samples is 8 just because. And we have it. We have a sophisticated source. One that starts powerful. It dies off over the trail. And of course, it ultimately just disappears. So we'll have an explosive event as opposed to just an ongoing event where it's just always sourcing fire and smoke and stuff. So if we got lucky, we could just say, we just put that in and see what we get. Maybe we'll get something interesting. So we're definitely getting something, but what was that? Did you see that little puff that showed up all of a sudden? The little herpes infection. Uh-oh, don't want that. Why is that happening? Well, that's happening because that's what we're giving it. If you don't believe me, let's look at the source. But then you'd say, but I don't see it. But that's because we're not seeing everything. And in fact, if we go all the way back up to the particles, we still don't see it. But check this out. Max substeps is 2. We're doing this twice per frame. That meaning every half frame, we're sourcing on those frames as well. We're not checking those sources. What if I clicked on this? Global animation options, playback, integer frame values. Turn that off just for a moment. Uh-oh. Crazy. Sweet rave party, but not useful for our sim. And you can see how at first it was fine. The reason why it starts happening is because we're trying to interpolate from one frame to the next. We're trying to interpolate from frame 11 to frame 12. And to do that, it has to say, well, halfway between these frames, that point should be halfway between where it was before. But the point numbers are changing. Point numbers are changing because particles are being created and particles are being destroyed. So what was particle 12 on one frame might be particle 25 on another frame. So that's what this is. It's interpolating between the wrong points all over the place. Now, we need our particles to be created and destroyed, so we can't change that. But what we can tell Houdini to do is don't interpolate between the point numbers. Remember that every particle gets a unique ID attribute. Those don't change, even if their point, order, or number changes. So to a time blend down right after our popnet, and you'll see immediately that it works now. Why does it work? Because time blend's main purpose is for a certain time period, which right now is 1 to 100. In fact, that reminds me, we're still simulating to frame 240. We definitely don't want to do that long. Change this to 72. Now that we're actually doing our actual particle sim, that means we're actually doing our actual explosion now. So change it to 72. But so that's within our frame range. So what are we doing? We're interpolating. And what are we interpolating based on? The point ID attribute. Here, it's already here by default, because this is a common enough thing that we want to do. So once that's fixed, that means the volumes will be fixed also. So we can look at the subframe volumes here, which were, of course, wrong before. And that means, of course, down here, and I'm just going to turn off, or rather, I'm going to turn back on integer frame values. We don't have that weird herpes rash anymore. Excellent. So what we have is, what we asked for. We had a spindly little thin source of flame and temperature, and that's kind of the output we got. I mean, you might be wondering, well, where did all the expansion and everything else go? Well, before we had a big sphere of expansion and it acted accordingly. Now we just have little bits of expansion, so we just don't see that much. So we need to compensate for that. So first up, I would say go to our source here and say 10 times as much. So what does that look like? So there you go. It's now 10 times as expansion. I think I put 109. Let's keep it clean. Let's make it an even 100. But you get the idea. It's much bigger and blobbier now. I would still say, though, that we can improve on this, of course. And we're only talking about the general shape right now. I mean, of course we need to break up the actual surface into having more detail. But even the general roughed-in shape that we're going for right now needs a lot of work. I would say, for one, this isn't a very hot explosion. It's not rising very fast. And that's because we never really, we talked about the buoyancy before, but we never actually modified it. We talked about the heat here, the reference temperature in kelvins. Right now it's kind of just like a campfire, but this is a gasoline explosion. It should be extremely hot. So let's double it. Let's double the temperature here. And again, you could play with the buoyancy scale as well, but I like doing it on here. So it's rising more. Let's just make it rise a whole lot more. Let's just do 3 times the ambient temperature. And now you can really see it ballooning up now. You can see it boiling up, and you see these rolls and things like that. And that's what we're going to get from a very hot explosion. So that's looking better already. And again, whatever our input is going to be, if we changed our particle sum around, and we said, let's try doing, let's change the seed. We talked about that earlier. So the seed is now 2. We'll have a whole different explosion now. Still interesting. Because our settings are just being applied to a different input now. Oh, I can see the particles back there. But this is an even more interesting explosion to me. It's kind of nice and balanced. So that's the kind of things that we're gonna be playing with. Again, you might find the need to tweak the actual flames tab here, but it's probably pretty good for now. Sweet. Let's talk about adding in a little bit more velocity into this.